Okay, this video is using substitution. So this is another nonlinear system, and it says solve the system by substitution. So with substitution, I'm going to go ahead and I'm going to take this second equation right here, and I'm going to rearrange it to where y is by itself. So I'm going to subtract the x, and I get 4 minus x. So I'm going to take that's from the second equation, and I'm going to plug it into the first equation for that y. And what that's going to do is it's going to get it to where my equation is in all x's, not x's and y's. So I looked at the bottom equation, looked way easier to rearrange because it was linear. There were no squares or anything. I got y by itself, and I took this piece, 4 minus x, and I substituted it in for y. Notice how I put in parentheses so that I would know that with this minus sign, since I'm subtracting y, I had to distribute the negative. So I have x squared plus x minus 4 plus x equals -1. Okay, let's go ahead and combine like terms. So x squared plus 2x minus 4 equals -1. Now let's get it equal to 0 by adding that 1 back over. All right, so this is where I'm at. Now, I'm going to go ahead and write it up here just so you can see better. So when I have a quadratic, I have 5 options to solve. I can graph it and look for the x-intercepts. I can use square roots. In this case, this isn't a good method because of this right here. I could do completing the square, and I could factor it, and I could do quadratic formula. And I know you're tempted to use quadratic formula at all times. This one factors really quickly, so let's factor this one. So we're going to factor, and we're going to say it's got to multiply to AC, which is -3, and it has to add to 2. So that's going to be either a -1 and 3 or a 1 and -3, and it is this set. So since it starts with just x squared, we can do x minus 1, x plus 3. If there was a number in front of x squared, I'd have to factor using the box. So if you set that equal to 0, you get 1. And set x plus 3 equal to 0, you get -3. Now, you don't just stop there. Those are your x values. To find your y values, you're going to take your x value and you're going to plug it back into one of these equations. I would go for this equation right here. We already rearranged it, so y is by itself. So if you plug in 1, 4 minus 1 is 3. So that goes right here because we did 4 minus 1. And if you plug in -3, 4 minus -3 is like 4 plus 3, which is going to be 7. And so these 2 points right here, 1, 3, and -3, 7, these are the 2 points that are solutions. If you had graphed them, these would be the 2 intersection points. Okay, let's go look just real quick at setting up substitution on this one. It's on the second page. So we would take, this is already y equals, which is perfect. So I don't have to rearrange it. So I would take this -2x plus 5 and substitute it back into the other equation. So I had x squared plus 3x plus -2x plus 5 equals 0. So if I simplified, then I would get x squared plus x plus 5 equals 0. Now this one doesn't factor. If you think about what multiplies to 5 and adds to 1, that's not possible. So since it doesn't factor, using the quadratic formula would be a better choice. So I'd have -b plus minus the square root of b squared minus 4ac all over 2a. And so that would be -1 plus minus. You plug in that square root into a calculator and you're going to get -19. That's going to get you an imaginary solution. So what that tells us is this has no real solution, which means that it does not have any intersection points.